Okay, so my name is Verrriah McGhee,
My name's Gustavo Silverio.
And I'm Lorianna Ayson.
and our topic is about infrared spectroscopy and the greenhouse gas effect. So, what is IR spectroscopy? So, IR spectroscopy refers to the infrared radiation part of the electromagnetic spectrum, basically the vibrational region of it. Um, Infrared radiation is essential to Earth's atmosphere. Earth's atmosphere absorbs the infrared radiation emitted by the sun and re-emits it as a long wave radiation, and what we feel is heat. So basically, infrared radiation is what we feel is heat. Energy radiated from the Earth's surface as heat is absorbed and re-radiated by greenhouse gases. In other words, it's just the heat, and it's responsible for warming and maintaining the warmth of Earth's lower atmosphere. In practical IR spectroscopy, the infrared radiation of a sample is taken by passing a flare of light through a sample. When the frequency of the vibrational bond matches up with the infrared radiation, then absorption occurs, and that is what is recorded. And this is what you can see on my slide here. This is an example of the IR spectroscopy of vanillin, which is something that I've done I recorded in one of my labs. Um, so that that is the example of it. This technology records these absorption parts to identify components of gases or compounds. Something in order to monitor the atmosphere's infrared radiation, we use something called the FTIR, which is the Fourier transform infrared spectroscopy. Like I said before, this technology records the absorption parts to identify components of gases pollutants. Since one of the IR spectroscopy abilities is to identify compounds through characteristic absorption, it's easy to identify abundant gases pollutants. Through using this technique, scientists have been able to identify how the overall absorption of infrared radiation by the most common greenhouse gases has proven to be detrimental to Earth's atmosphere.
So, what is the greenhouse effect? It is a way for Earth to protect itself from the sun's radiation by creating a protective blanket near Earth's atmosphere, by capturing specific gases through solar heat and re-emitting it as infrared radiation. Some of the gases that play a role in this process includes carbon dioxide, methane, and water vapor. What has been affecting the greenhouse effect? Since the early 1850s, human activity like coal burning has been diminishing this layer of coating that protects us. Another factor that includes the greenhouse effect is deforestation, which diminishes the Earth's ability to absorb and store carbon dioxide through photosynthesis. This leads to the planet warming up and radiates excessive energy in order to restore equilibrium between incoming and outgoing energy.
So, how is IR spectroscopy and the greenhouse effect related? There are gases that allow incoming solar radiation to pass through them while allowing outgoing infrared radiation to pass, meaning that they don't trap or emit solar or infrared radiation. However, Earth's atmosphere contains other gases that can trap infrared radiation. These gases are referred to as greenhouse gases, which Gustavo had mentioned earlier. In a greenhouse, there is a glass covering that permits visible light to come in and be taken in by the plants and soil inside. The plants and soil later release the absorbed heat energy taken from the light coming in the form of infrared radiation. The glass of the greenhouse then takes in the infrared radiation and sends some back into the greenhouse. Doing so maintains a higher temperature inside, even when it's colder outside. This combined effect is referred to as the natural greenhouse effect and is responsible for maintaining the Earth's average global temperature at around 15 degrees Celsius. And you can see that in the pictures on the left, which show the gases that are absorbed and involved in the greenhouse effect. You have CH4, NO2, O2, CO2, and H2O.
So how does this relate to quantum mechanics? In quantum mechanics, we learned the harmonic oscillator model. It serves as a basis for vibrational analysis in larger molecules, which are commonly used in chemistry today to interpret infrared spectra. And next slide. And these are our references. Thank you.